Aloha, Richard Halverson here. This is ITS128, and today is September 22nd. And so let me share my screen. All right. Okay, so here we are, and this is ITS128. And if I look at the syllabus, we are see, what time did September 22nd. So we are in here, and so we're doing branching, and I think we covered up to section 4.3 last time. If I look at the YouTube playlist and look at the left, video 7, and 4.3. Okay, great. All the way to the end. Okay, all right. So let's start with 4.4. All right, so I guess we're going to learn about relational operators. We haven't covered relational operators yet. We sort of have. Yeah, we've sort of covered relational operators. This is where we ended up. Okay, so let's see. So relational operators are used, to compare, and the result of evaluating an expression with relational operators, the result is going to be true or false. Okay, and so since the result is true or false, you can use that for the if part of an if statement. So you can use it to test for branching. And so there's this one, which means if A is less than B, if there's greater than, there's less than or equal to, and there's greater than or equal to. And so this tests your understanding of the meaning, indicate whether the expression evaluates it true or false. If see, I'll make sure no one wants to say anything. If X is Y and Y is 7, so that means X is less than or equal to Y, so it'd be true, so on. Creating expressions with okay, so this tests to make sure you understand how to use the relational operator. So to say, so testing if this variable is greater than 10 is greater than 10. If it's less is greater than or equal, so it's greater than or equal. See, is this right? Yeah, greater than or equal. This 5 or greater. Well, that's the same as greater than or equal to. 5 or greater is the same as greater than, I think it is. So anyway, is a negative number. Okay, so anyway, so you have to make sure that you understand how to use those. Those should be kind of second nature. And for detecting ranges with if else statements, I thought we kind of did that already, but here we're using the if, and this detects below 16. This is going to detect between 16 and 25. You see, if it's less than 16, it's going to go here. Otherwise, if it's 16 or greater, it's going to continue down. So if it gets to here, it's 16 or greater, and this caps it off at 25 or 24. It's got to be less than that, and it's an integer, and it shows over here what which or what range each of these captures. And the fact that anything under 25 is caught down here. So if it gets to here, so that's how the ranges work. This is all common stuff. So this says the second branch range. What am I supposed to say here? Oh, the ranges. Okay, so it would be for the second branch range, it is between 10 and 19, I guess. If it's less than 10, it's up. Otherwise, it's 10 all the way up to 10 and 19. What do I do? Dash 19. Yes. All right. So anyway, make sure you know how to do that. Complete for the multi-branch if then else or if else. So the second branch less than 200. So this is less than 200. Yeah, and this is going to be greater than or equal to 200. So that's, oops. Oh, something is less than 200. USER underscore num. All right. Oh yeah, can do that too. All right, so make sure you understand that. Let's do a harder one. Oh, here, let's do a challenge. Okay, enter the output for the branches with relational operators. Enter the, okay, so let's start it. So we have a variable called numEggs, and we're setting it equal to 6. And so now we go, if numEggs is less than or equal to 4, it's not less than or equal to 4, so we do the else case, and the else case says print E. So that's E followed by enter, and then we're going to print the K, no matter what. Okay, let's do one more. If numBikes is greater than or equal to 6, no, it's not. It's equal to 5, so it's less than 6. So it's going to print E, and then it's going to print K. So anyway, make sure you finish that. So we want to make the code where right here, we're going to put some code right there where if the user age is less than 20, it's going to print this out. So it's just really easy. If the user, well, what do I do? Press start first. Here we go. If the user age is less than 20. So that's pretty easy. What does the next one look like? Less than -15 or -15 or more. All right, so this looks pretty easy. I'll do this one and then you can. It's just user num. If it's less than -15, yeah, I think that's all it is. Yeah, so anyway, make sure you can do that. You can do the next one. What's next? Write an expression that will, okay, let's see. Write an expression that will cause $1 or less to print if the value of num cents is less than or equal to 100. So if num cents is less than or equal to 100. Is that all it is? Yes. You can do the next one. Greater than or equal to -10, less than -10. Just like the one up above. All right, what's this one? Detect ranges using branches. Okay, so let's start. What am I supposed to do? So the input is 0, so x is going to be equal to 0. If x is less than 15, print D. Okay, yes, x is less than 15, so I'm going to print D. And then that's it. No. What's next? 34. Is it less than 5? No. Is it less than 30? No. Is it less than 50? Yes. So print C. All right, good. You can do the next one. What's this? Multi-branch if else statements. Print century. Oh, okay. Write an if else statement with multiple branches. If the year is greater than 2101 or great, okay, let's see. If year, that's this, it's that. If year is greater than or equal to 2101, print distant future. Okay. Otherwise, else, if the year is greater than or equal to 2001. If that's the case, then print 21st century. Otherwise, boy, this is getting pretty. Otherwise, if the year is greater than 1901, then print 20th century. Else print long ago. All right. So 2101, so greater than or equal to 2101, greater than or equal to 2001, greater than or equal to 1901, and earlier. Okay, run. All right, looks like it worked. Okay, and it tested every branch. When you test your code, you should test every branch, every path through your code, and that's what this is. did it twice here. And you can also test the boundaries too. Test 2000, 2001, 2002, and so on. All right, operator chaining. Oh, okay, this is something that that's unique to Python. You don't have this in other languages. So you can do this to determine whether B is greater than A and less than C at the same time. So write a relational expression using operator chaining. X is less than Y but greater than Z. So X is less than Y, but X is also greater than Z. Greater than Z. Is this right? Yes. X is a non-negative number less than 10. So X is greater than 0, but it's also less than 10. Less than 10. Oh, 100. 100. X is greater than or equal to, yes, 0 is also a non-negative number, so it's greater than or equal to. Is this right? All right. All right. It works. Okay, challenge. Write an expression that will print in high school if the value of user grade is between 9 and 12 inclusive. So asks for the user grade, and if it is if 9 is less than or equal to user grade, and it's also less than or equal to 12, then in high school. So I think that's right. Yes. Detecting ranges using local operators. Detecting ranges using logical operators. All right, so so this is using and, or, and not. Well, you know, this is just so you can cascade, and this is how you'd normally do it if you didn't have those operators like you had before. These what do they call them? Chaining, operator chaining. Okay. Yeah, they don't have operator chaining in many languages. All right. So you do it this way instead. So anyway, and, or, and not is just like you'd think, just like, you know, you've learned. So, you know, if this is true and this is true, then the whole thing is true. For this one, only one of them has to be true, and then the whole thing is true. And for this one, if you know, the not does the reverse. If not A is if A is true, then not A is false. If A is false, not A is true. So indicate whether the expression evaluates to true or false. X is 7, Y is 9. X is greater than 5. Yes, it's true that X is greater than 5. It's true that X is greater than 5, and it's true that Y is less than 20. So this is true, and this is true, which makes the whole thing true. I think it's true, yes. Let's see, we're using and, so that means both sides have to be true. Is this true? No, it's not true. Since we know that this is not true, we don't even have to evaluate this. It doesn't matter what this is. It's enough to just evaluate this. So we know it's false. Well, I don't know how it works in Python, but in some languages, you want to know if this is evaluated, because sometimes the evaluation of something can cause something to change. But anyway, so here, if this is true, then we don't even have to evaluate this. So let's see, is X greater than 10? No, it's not. Okay, now we do have to evaluate this. Is Y less than 20? Yes, it is. So that means it's true. All right, so you can do the rest of them. Detecting ranges with logical operators general. Okay, so using AND to detect if a value is within a range. Yes, okay, so see, this is how you would do it if you didn't have these chaining operators. So you can go through that. Assume X is an integer. Which approach uses a logical operator to detect if X is in the range? If X is in the range 1 to 99, uses a logical operator to test to see if X is in the range 1 to 99. I think it's this one because it's using a logical operator, which is AND, to detect if X is in the range 1. So this is X is 1. Anyway, let's see if it's right. Okay, first, yes. So anyway, you can do those. Boolean and logical operators. Okay, so variables can take on Boolean values, and Boolean, of course, is true or false. It's got to be capital T. Okay, make sure it's capital T RUE for true, capital F false for false. Otherwise, it's a variable name. Must be capitalized. All right, so so if this is a Boolean variable, then the right side has to evaluate to either true or false. So you have some sort of expression over here, and when you evaluate it, it's going to be true or false. And so is it true or false that my val is less than 3? So that's all, whatever it is. Are used to represent logical operators, common used expressions. So Boolean and Boolean or, oh yeah, well, obviously. Okay, so here we're doing Python expressions. So this is 17, 18, 19, 20, 21, 22, 23, 24. Age is 19, I see. All right. So this tests not, so days is greater than 10. So this is false because it's less than 10, but then not false is true. So complete the expressions to detect the desired range. So days log is greater than 30, but less than 90. It's greater than 30 and less than 90. Greater than 0 and less than 100, between greater than or equal to 10. Are they all and? Not valid as either it's or. So this is an or. I see. Just right. Okay, anyway. Yeah, that's an or. All right, what's this? Creating expressions with logical. Okay, so numdogs has a minimum of 2 and a maximum of 5. And why do I have to put a, do I really have to put parentheses around there? Oh, dogs. Oops. So I really have to put a parentheses around it, huh? Oh, no, I don't. Okay, so it's because I said docs instead of dogs. Wage is greater than 10 and less than 18. Use these and not those, okay? Okay. If wage is greater than 10, and wage do I need to use, am I supposed to use the and? Oh, I'm supposed to use logical operators. Okay. And wage is less than 18. And I'm supposed to put parentheses around the sub-expressions. I guess they want me to put parentheses around the sub-expressions. All right, so anyway, num is a 3-digit positive number like that, are 3-digit, but are not. Oh, num is a 3-digit positive number. And I'm supposed to test to see if num is a 3-digit positive number. And num is less than or equal to 999. Yeah, all right. Okay, TV channels. Okay, so if it's between 2 and 499, between 2 and 499, it's a standard, or whatever this is, standard. If it's greater than 102 or less than that, it's high definition. Otherwise, E for error. What am I supposed to do here? Okay. So 500. All right. So anyway, supposed to. That's nice. Okay. If channel is 300, what does the if statement's expression evaluate to? Well, it would be it's greater than or equal to 2, and it's less than or it's true. This one would be false because it's got to be between 102 and 1499. Wait, I'm sorry. If the user channel does the else ifs expression, oh, no, it doesn't, because this evaluates to true and then this is done, and so then it jumps out. So I think the answer is no. Yes. All right, so you can finish that. Detecting ranges implicitly and explicitly. Yeah, well, this is pretty obvious. From this point here, this is saying that if the channel is 300, then this evaluates to true, and these aren't the next one is not even evaluated here. If x is less than 0, then this is executed. If x is not less than 0, then that means that x is greater than or equal to 0. So you don't need to have this test here. You only need this test. And then if this is false and this is false, then we know that x is going to be greater than or equal to 11. So we don't need this, and we only need to look at this, and that's the point here. This part is implicit. So anyway, I'll make sure you understand that. Each pair of statements does the second if-else statement detect the same ranges as the first if-else statement. All right, this yes, because this is the opposite of this. So we don't need, this is redundant, I think. All right. Less than 130, greater than or equal to, okay, so less than 130, oh, no, it's not the same thing. No, it's not the same thing. This is the redundant part. So this is the redundant part. This is the anyway, so it's no. All right, so you can figure that out. Oh, a challenge activity. Write an expression that prints eligible if user age is between 18 and 25 inclusive. If user age is can I do the 18 less than or equal to user age less than or equal to 25? Can I do that? Yeah, good. All right, what's next? Detecting ranges with gaps. Okay, oftentimes ranges contain gaps. Movie theaters often give ticket discounts to children and seniors. The gap is the group of people between age 13 and 64. So this is how you do that. Read the age. If the age is less than or equal to 12, here's that discount section. Or if the user age is greater than or equal to 65, you use it. This is that part, and this is everything else. So you can go through that. I'm allergic to my cat. All right, so let's see what this is. Detecting ranges with gaps and selecting. In the above animation, what is the age range for a child ticket discount? Let's see, less than or equal to 12. Um, 12 and under. So I guess it's this one. It's not this one because this is a, well, it's an integer. I wonder why this one wouldn't be the correct answer. Well, the correct answer is, well, I'm going to say this. User age is less than or equal to 12. Okay, yes, because so in theory, the age can be negative, huh? Yeah, right. So it's this, yeah. Yeah, see, yeah, it's because in this code, there's no reason why you can't enter a negative age. So, you know, and it's going to say, it's going to give the person with the negative age this discount. And this does not include any negative age. So anyway, in the above animation, what is the age range for a senior ticket? It's going to be greater than or equal to 65, all the way up to 1 million. Greater than or equal to 65. So is it this one? Yes. What is the range for the last branch? It would be less than or equal to 0, greater than, be 1 to 100. All right, see that? 1 to 100. So you can do that one. Range with gaps using logical operators. All right, so here, this is explicit ranges with gaps. Okay, so this looks for office number between it's greater than between 100 and 150, and this is between 200 and 250. And so if it's above 150 but below 200 or whatever, okay, so here, if it's the first range, and this is the second range, see, because this is the same as this, then you can do that. Yeah, so that's pretty straightforward. Linebacker is 40 to 59 or 90 to 99. So whatever. 40 to 59 or 90 to 99. I think it's the first. Okay, it's not this one because this would not include 40, and we are including 40. This one would include 40. Oh, but this would include 60. So anyway, so it's this one. Must be this one. Let's do a defensive lineman. 50 to 79 or 90 to 99. Okay, so not this one because it doesn't include 90. Not this one because it includes 89. This one is 90 to 99, and it's 50 to 79. So it's this one. All right, let's do a challenge. Enter, start it up. X equals 3. If X is less than 3, it is this because it's less than 3. I mean, it's less than 6, and it is greater than 2. So I'm going to print A. What's next? It's not greater than 8. It's an OR, so let's try the next one. It is less than 2, so it's going to be A. Okay, you can do the next two. That's what's next.
Can I ask you a question?
Yes.
I see you have to do the enter after input. Is
Yes.
that because?
Pardon?
Yeah, because I see you had a, after B you put an end. You have to do an enter. If
Yes.
you don't do an enter, the answer wouldn't.
Sometimes. Sometimes. Let's try it. Okay, so let's do the next one. Sometimes they're testing you that. Yeah. So let's do another one here. 5 is less than 6. Okay, so I'm going to do A. I'm not going to do enter. Oh, yeah. See, it wants the enter. See, because this print actually does always put an enter after it. So you gotta. So the answer is yes. You have to use the enter. You have to do the enter.
Thank you.
Mm-hmm. All right. Okay, so here, so user age is 26. Note that more than one if statement can execute. Yes, more than one if statement can execute, and that's because you're not using elif. You're not using else. You're just having a single if statement, and then the next if statement is just a standalone if statement. The next if statement is a standalone if statement. So let's say the user is 26. Is user age less than 16? No, it's not. Is user greater than 15? Yes, it is. So it's going to print that out. Is user age greater than 17? Yes, it is. So it's going to print this one out too. Is user age greater than 24? Yes, it is. So it's going to print this one out too. And then is user age 34? No, it's not. So when user age is 26, it's going to print out this one and this one and this one. So you can click through that. I must have done it already. Okay. So determine the final value of num boxes. So we start out with num boxes equals 0 and num apples is equal to 9. So is this true? Yes. So now num boxes is equal to 3. Is this true? Yes. So now we add 1 to num boxes and the answer is 4, I think. Oh, -1. So it's 3. Both of these execute because num apples is 9 and it's minus. So I did pluses. So anyway, I still got all the points. All right, here, this is true. And, but this is true. So this is not going to execute, even though it happens to be true. So only this is true, so this executes because num apples is less than 10. But this does not execute, but this does. So num boxes is going to equal 2, I think. Yes. All right. Let's do a challenge. Num items is equal to 6. Is this true? Yes, it's true. So this is not going to execute, and this is not going to execute. So we print out 6. We print out C and an enter. Oh, then we print out M and then enter. What did I do wrong? Oh, I'm not paying attention, am I? Let's try it again. Num items is 5. Is this true? Yes, it's true. So B is printed and then R is printed. Yeah, B, R. All right, I gotta do another one. This is not true. This is true. So the F prints and then the K, the F prints and then the M prints. F, M. We can't seem to reach our server now. Well, that's me. That's what am I? Which network am I on? Okay. Well, anyway, I'm pretty sure that that would be right. Let me refresh this thing. All right. Anyway, so you can do that one. What's this one? Write multiple if statements. Okay, so I'm supposed to write all this. Okay. If car year is before 1968, print, then print probably copy, paste, do that. If after 1971, if after 1971, then do this. Probably has seat belts. If it's after 1992, if it's after 2000, after 1992, after 2000, tire pressure monitor, anti-lock brakes, end each phrase with a period and a new line. Okay, remember that print automatically adds a new line. Okay, so it would print this and it would print that. Okay, so let's see. Very good. All right, you can do the next one. What is the next one? You can do that. Okay. Nested if else. See, it's nested. You have an if, else, and then there's an if inside of an if. So if user choice is 2 and num items is 5, okay. If this is false, then it's going to check this one. If this is true, then it's going to do another if. And then it prints this if this is true, otherwise it prints this. So you can execute that. Well, all right, participation. Determine the final value of the sales bonus given the initial values. Okay, so here's the code, and here's the initial value. Sales type is 1, and sales bonus is 0. So this is false, so it's gonna do an else. Sales bonus equals sales bonus plus 1. So this is this, and so it's gonna be 0 plus 1 is 1. All right, what's this one? Sales type is 2, so that means this is true, and then it's going to come down, and sales bonus is 4, so this is true, so sales bonus is going to equal 10. So I think it's 10. Yes. All right, you can do the last one. Comparing data types and common errors. Okay, so which comparisons will not result in a syntax error and will consistently yield expected results? Values have types denoted in their names. Got it. Okay. So floating point types should not be compared using equality because of imprecise representation of floating point numbers. Okay, it has to do with well, it's pretty obvious. Also, operators can also be used for string type. Yeah, right. Okay, so which comparisons will not result in a syntax error and yield consistent results? Okay, so if my int is equal to 42, well, int, it's presuming this is an integer. This is okay. This is fine. Okay. This is not okay because if this is a floating point number, it could be 3.14159 or 3.1415. Nothing. So this is not okay. Does not result in a syntax error, but due to imprecision, it might yield unexpected results. This should be okay. Yes. All right. All right, so this is going to be a type error because this doesn't make sense. If you're comparing an integer with a string and it doesn't make sense. All right. Numbers are arithmetically compared. Strings are compared by converting each character to the number ASCII value and then comparing each character in order. So, you know, the ASCII value, you'll learn more about that, but ASCII, ASCII, these are the, where's a nice ASCII table? Basically, can I just see an ASCII table here? Well, let me look at one of these. Well, anyway, it's the numbers that represent these characters. I mean, there's, you know, like 32 decimals of space, and these are characters, and these are letters, and these are uppercase letters, these are lowercase letters. Turns out the lowercase letters are higher up than the uppercase letters, and so on. So anyway, that's ASCII. Comparing various types, click the expression that is false. That should be true. Is this false? I don't know. What's the answer? So the expression that is false. Okay, well, this is false. Yes. All right, so anyway, you can make sure you understand this. Okay, well, you can read this to get through that. All right, common branching. Oh, I see. This is a section on common errors. What is the right error results? Okay, so this is true, then this is true. This should be fine. 4. This is not right because this should be a double equal sign. So this is going to be error. I see, that's a common error. If this is greater than that, I don't see anything wrong with that. 3. Okay, here's a challenge. It's the last one. Let's see what this is. Fix the error. Oh, is that it? Is that it? Oh, whoops. Try again. Try again. Do I get to try again? Is not to. It's not to. All right. Okay. Well. What? Oh, I'm done, right? Okay. I got the points. All right. Well, we are done with 4.8, and very good. So next time, which is I guess tomorrow, or we're gonna have one more class this week, and we'll try to finish it up. Oh, yes. You're welcome. Are there any other questions? All right. See you whenever the next class is scheduled. I guess it's let me just quickly check here. Thursday, that would be tomorrow at 11:30. See you then. Thanks for watching.